give all solutions and multiplicities. Solutions are also called zeros, and so what we're doing is looking for what value of x would make 0. We've done this before. For instance, you look at this and say, well, if x was -6, that would make 0. And look at this x, and if this x was +4, that would make 0. 4 minus 4 is 0. A lot of students struggle with this one because it's easier than you think, but the number 0 would make 0. So we've got 3 different solutions, 0, 4, and -6. 0 has multiplicity of 1, and literally all that is the exponent here. 4 has multiplicity 2, and again, that's just this exponent here. -6 has multiplicity 4. All I'm looking at is the degree or the exponent on that power. All right. The multiplicities have something to do with how the graph looks at those certain zeros, but that's not important. I don't need to go into that right now. Number 12, we're going to factor using the grouping method. So the grouping method, you want to put parentheses around the first 2 and parentheses around the second 2, and the last 2. Look at a GCF. We're going to factor, but we're going to use a GCF around each group. So in the first group, you've got a 12 and a 15. Both of those are divisible by 3, and both of them can be divided by n squared. So in that first group, I see a GCF of 3n squared. So think about factoring that out, or think about distributive property. 3n squared times 4n would get me back to 12n cubed, plus 3n squared times 5 would get me back to 15n squared. So that's the first group. Now look at the second group. The second group, you've got a 32 and a 40. Both of those numbers are divisible by 8, so I'm going to put a plus 8 right there. And if you take out an 8, or think about distributive property, 8 times 4n will get you back to 32n, plus 8 times 5 will get you back to 40. So we've done GCF a couple of times. That's the grouping method. And what's important to notice is you've got this match here. And so really what we're going to do is another GCF. We've got this 4n plus 5 in common, so write it down. If you factored it out, it's like you kind of pulled that out of the problem. You'd be left with 3n squared plus 8. And that is factored. That's the name of the game. That's what we're trying to do there. Factor means write it as multiplication. We're finished. So then 13 is similar, except this time we have to solve. So start it the same way. We've got these 2 groups. In the first group, I see they both have x squared in common. X squared times 5x plus 2. In the second group, both those numbers have a 5 in common. So take out a 5, and remember, it's distributive property, 5 times 5x, and 5 times 2. The whole key to this is seeing this match. If you don't get this match, then you screwed up and you did it wrong. So we have 5x plus 2, and then x squared plus 5 left over. Now don't forget your equal 0. We are trying to solve this. So the first part is easier than the second part. When we talked about multiplicities, you were able to do this in your head, find the x number that makes 0. If you can do that in your head, then great, do it in your head. If you can't do it in your head, we can do algebra. 5x plus 2 has to equal 0. So subtract the 2 over, and 5x equals -2. Divide by 5. And we get x equals -2/5. The other one's a little bit trickier. X squared plus 5 equals 0. So we're going to subtract the 5 over, and we get x squared equals -5. We're trying to isolate the variable, so we're going to do a square root on both sides. But it has to be a plus or minus root. Okay, a plus or minus square root on both sides, and so we get x equals plus or minus square root of -5. Now, it may have been a while, but remember the square root of a -1 is I. That's an imaginary result, a non-real solution. So we can pull that I out and say this is plus or minus I times the square root of 5. And so at this point, we have three solutions. We have one real number solution, negative 2/5. And then we also have I times the square root of 5 and negative I times the square root of 5.